Hello everyone and welcome back. Today's our topic is plate tectonics and earthquakes. Before we start our video, do subscribe to my YouTube channel. Have you ever wondered why the earth shakes? Or how massive mountains like the Himalayas were formed? Beneath our feet, the ground isn't as solid as it seems. The Earth's crust is broken into huge slabs that are constantly shifting, and sometimes that movement causes earthquakes, volcanoes, even entire continents to drift apart. In this video, we're diving deep into the powerful forces of plate tectonics and earthquakes and how they shape the world we live in. Earth's structure and what is plate tectonics? To understand plate tectonics, we have to start with the Earth's structure. Earth is made up of several layers. The Earth is made up of four main layers. The inner core, a solid ball of iron and nickel. The outer core, a molten layer of metal. The mantle, which is hot, thick, and flows slowly like caramel. And the crust, the thin, rocky layer on which we live. The crust and the top part of the mantle together form the lithosphere, which is broken into about a dozen major pieces called tectonic plates. These plates float on the semi-fluid layer beneath, called the asthenosphere. Plate boundaries are the movement of tectonic plates creates different types of boundaries, and each type affects the Earth in a unique way. 1. Convergent boundaries. Plates move toward each other. When two oceanic plates collide, one sinks beneath the other, a process called subduction, forming deep ocean trenches and volcanoes. When an oceanic plate meets a continental plate, the denser oceanic one subducts, forming volcanic mountain chains like the Andes. When two continental plates collide, they crumple and push upward, creating massive mountain ranges like the Himalayas. 2. Divergent boundaries. Plates move apart. This happens at places like the Mid-Atlantic Ridge, where magma rises and creates new crust, forming undersea mountain ranges. 3. Transform boundaries. Plates slide past each other horizontally. The most famous example, the San Andreas Fault in California. This movement can cause intense earthquakes. What causes earthquakes? Earthquakes happen when stress builds up between plates and is suddenly released. The rocks along a fault line, a crack between tectonic plates, can get stuck due to friction. But when the pressure becomes too great, the rocks break and slide, releasing energy in the form of seismic waves. These waves travel through the ground, causing the shaking we feel during an earthquake. The point inside the Earth where this break occurs is called the focus. The spot directly above it on the surface is the epicenter. Next is how to measuring earthquakes. To measure earthquakes, scientists use tools called seismographs, which detect the vibrations in the ground. Earthquake strength is measured in magnitude, often using the Richter scale or more modern moment magnitude scale (MU). A 3.0 quake might feel like a truck passing by. A 7.0 quake can level buildings. Earthquakes can also trigger tsunamis, landslides, and aftershocks, smaller tremors that follow the main quake. Real-world disasters. Let's look at a few major earthquakes in history. The 2004 Indian Ocean earthquake, magnitude 9.1, triggered a tsunami that killed over 230,000 people across 14 countries. The 2011 Japan earthquake, magnitude 9.0, caused a tsunami and a nuclear disaster at Fukushima. The 2010 Haiti earthquake, magnitude 7.0, devastated the capital, killing over 200,000 and displacing millions. These tragedies remind us how powerful and dangerous tectonic forces can be. Studying and preparing for earthquakes. So how do scientists try to predict or prepare for earthquakes? While we can't yet predict exactly when an earthquake will strike, we can identify high-risk zones and monitor stress along faults using 1. GPS and satellite data. 2. Seismometers. 3. Early warning systems, which can give people a few seconds to take cover. Education, building codes, and emergency drills are also critical, especially in earthquake-prone regions. Conclusion and call to action. Earthquakes and tectonic movement have shaped our world, building mountains, forming oceans, and occasionally reminding us of nature's raw power. If you learned something new today, give this video a thumbs up and don't forget to subscribe for more science content. Have you ever experienced an earthquake? Share your story in the comments. We'd love to hear from you. Thank you for watching. Please do like, share, and subscribe.